that, Walter Haugen, FA Farm. Thank you.
Great. Well, thanks, Chris. I wasn't going to do a handout, but I decided to anyway. So I got it right here. So let me just pass that around. It's double-sided, so I'll just shoot that around. Okay, maybe I should have one. So. There you go.
How do I make the checkout since I don't have any?
Chris?
At this point, I think that's Chris Elder. Yes.
ELDER. Okay. Soils and soil building. And there's a lot of stuff out there, and there's a lot of nonsense. And so you could, the idea here is that you need to do the research and figure things out. So what I'm going to do is, because we have lots of preconceived notions, I'm going to give you some tools. Now you can do the work yourself and tailor some solutions for your own farm, your own garden, etc. We all have preconceived notions. It's just part of being human. And so we don't just look at the world and take in stuff. We have preconceived notions, and we look out through our eyes. The brain looks out through our eyes. We have worldview. We view the world. We have a worldview. There are three main worldviews: objective, subjective, and experiential. The objective is a worldview of science, and basically means anybody can replicate your experiment. They don't have to be part of the experiment. Subjective is the worldview of art, religion, humanities, and it's personal. You're part of the experiment. And you can't, you may be able to replicate yourself again and do it again, but somebody else may not be able to, just because you're a component. The experiential, great, thanks. And so the experience, did you get something?
No, I think there might be something.
Okay, great. So the experiential is based on keen observation and paying attention. And Scott Nearing, one of the mentors of Elliot Coleman, once remarked, just pay attention to what's happening with your plants. Pay attention to what's happening with your soil. That's all you need. And Scott Nearing was a big influence on me too. And okay, so we have this worldview, and that's one level. And underneath worldview, we have another level called the paradigm. The modern use of paradigm comes from Thomas Kuhn's book, The Structure of Scientific Revolutions, came out in 1962. And paradigm is just a model of how the world works. And the paradigm we have, they can take a lot of attacks. They can take a lot of bad data. They can take a lot of incommensurate, to use Kuhn's term, data and analyses, etc. But at a certain point, the paradigm might have to shift because it has to accommodate the new view of the world. Okay, classic example is the clockwork paradigm of Isaac Newton. He looked at the universe as a big clock, and everything's all the same all through time, and it's just like gigantic wheels and levers, and that's the way things work. Okay, well, Einstein came along and introduced the relativity paradigm and said, no, we got to factor in time. And you use the speed of light, and all of a sudden things were different when you factor in time. Okay, those are two deterministic paradigms. In other words, we can know what the world is like. And then quantum physics came in and said, okay, at subatomic level, things are just based on probabilities. Event A has a certain probability, event B has a certain probability, and it depends on what happens. It's not deterministic anymore. So this is a paradigm level. And the two paradigms we're going to be looking at tonight is feed the soil paradigm versus feed the plant paradigm. It's a model. Now below the paradigm level we have theory. And theory is an explanation of the world. And so, for instance, we have the theory of evolution based on a probabilistic paradigm. We have random mutation, natural selection acts on that, and we have increases in frequency, and we have speciation. Okay. That's a deterministic, a theory that uses a deterministic paradigm would be the theory of evolution by intelligent design rather than natural selection, or incorporating natural selection. So that's more deterministic. So you get these ideas that we have paradigms and we have theories that explain the model. Now, the very important theory for industrial agriculture is the MPK theory of Justus von Liebig. He's on your handout there. And he took Sprengel's law of the minimum, which says that your plants don't just use what's available, they use the minimum amount of one nutrient, and that holds everything back. And his example was a barrel made out of staves. If you have different lengths of staves in there, it's only going to hold as much water as the shortest stave. Okay, so he took that law as minimum, and he said, well, let's apply this to chemistry and agriculture. And he said, okay, all you need is nitrogen, phosphorus, and potassium, NPK. And that's what all of industrial agriculture is based on. That's what the land-grant colleges are based on. That's what the extension services, research services, all the research done by private corporations. It's what soil testing is based on. We look at NPK. Underneath the theory level, we have hypotheses, and that's how we test the theory. And so what we do is we take an idea, we try, how do we falsify the theory? And so we devise a null hypothesis. And so a null hypothesis in this case would be, let's say that there is no difference if we add NPK. And then if we can reject the null hypothesis, that gives us positive feedback to the theory. So we're going to use the hypothesis that there is no difference between fertilizer and non-fertilizer. Okay, so real easy to test it. You have two plots right next to each other. You're growing corn or wheat or something. And you have the same soil, same water, same tillage, same cultivar that you're planting, and same cultivation techniques, same harvesting, everything's the same. And you see if there's a difference between no fertilizer and NPK. And of course there is. So the chemical industries said, oh, this is great. And that led to the Haber-Bosch process, which is the process by which they use natural gas to take nitrogen out of the air and form anhydrous ammonia and nitrate fertilizer. Okay? So now all of a sudden you've got a way that you can just put chemicals in the soil and you can grow plenty of food. Okay. There's a couple of people, Sir Walter Haugen, who did his work in India for the British government, and Robert Odell in the United States, and they said, wait a minute, you're forgetting things. It's not just the yield now. What about the soil? What about sustaining the soil for years and years? And what about the nutrient levels of the crops? And of course, the NPK people say, oh, well, that's those are just externals. They're like the economists. They just throw away things that they don't like, and they call them externals. So the economists say, well, it's just price. You know, we can do this cheaper. We can make chemical fertilizer cheaper than growing cover crops or using animal manures, so it's just price. And they forget about pollution, they forget about the transportation costs, they forget about the dependency on cheap oil, all of that, those are externals. The same thing with chemical agriculture. And chemical agriculture is the way that we get 95 to 98% of our food. Okay, so the hypothesis or hypotheses have feedback into the theory, theory has feedback into the paradigm, paradigm has feedback into the worldview. And also, what we see in the testing we did, it says direct impact on the worldview too, all this stuff. They're all linked. So now we can see that the experiential worldview is very important. We pay attention to what we're doing. We have our little experiments going on our farm. We're looking at how we're growing our vegetables in our little plots, and that informs our view of the world. And the experiential worldview is an account. It actually tipped the subjective and the objective on its head and actually take in data, take in the view of the world without filters. So all these things are linked. Now, like I said, the two paradigms we're going to focus on tonight is feed the soil